Okay, hey everyone, welcome to ECE2300. This is our first lecture. I'm really excited to meet all of you virtually. I hope you're all well rested and ready to go for this new semester. I'm very much looking forward to work with all of you. Right, so this is our first lecture. Right? It's going to be divided into about two parts. I'll first tell you a little bit about this course, some important logistics and also the course motivation. And then I'll talk about this important concept called digital abstraction. Right? So we'll try to do a break in the middle. Right? Okay, so first of all, 2300 is actually one of the core courses of ECE. So in case some of you have happen to know the slogan of ECE, right? We have something called ECE can do everything, right? You can probably tell that I'm not really going right. So with the standard definition of this ECE, right? But what about CE, right? What exactly is computer engineering, right? I bet many of you have this question, right? What exactly is the difference between CE and CS, right? And also what's the relationship between CE and EE, right? EE. I'm gonna try to answer this question right later on in this lecture, but for now, let's just say that this is my own interpretation, right? C really means cool, and E means essential, right? I'm not actually even joking here, so I really mean it. Okay, so because this course, is actually about digital computers. If you look at digital computers, so they are indeed very cool and essential, right? So they are literally everywhere. And you can find this, computers, right? So I'm pretty sure they're on your desk, right? They are in our pockets, right? And these days, actually, in many cases, we have to rely on these powerful computers in the cloud, right? You often call it data center servers, right? Of course, these data center servers are not really in the cloud, right? But these things are, right? So these things can fly, okay? And there are many other things, right, that are digitally powered. So just to give you a little bit of history here, you guys are probably too young to know this, right? About 20 years ago, this term digital itself is already a buzzword. Okay? If you happen to own a digital camera, you're probably one of the coolest kids in your class. And a few years ago, actually a few years later, this digital TV or this HD TV, right, high definition TV, become really trendy. And later on, even this digital is not cool enough anymore, right? So then people are starting to use this thing, right? So people are starting to use a new buzzword. You can probably guess, right? So this is where this buzzword "smart," right, becomes popular, right? Everything is smart, right? Smartphone or smartwatch. Right? People these days are even building a smart city. Right? But if you look at more recently, right, even this term "smart" is kind of outdated now. I actually grouped these two things intentionally. Hope that you guys can see my pointer, right? It's although moving slower than I expected. So what is the keyword here? Anyone want to chime in? Just unmute yourself and hopefully turn on your video. Let me know. So we just talk about digital, right? Smart.
Autonomous.
Very good. Lauren, right?
Yes.
Right, very good, Lauren. Autonomous, right? So this is the new buzzword. Okay. So this is everywhere, right? And they are really changing every aspect of our life as well, right? It's already changing the way we communicate, right? It's changing the way we socialize. It's changing the way we do shopping, right? And of course, it's changing the way we are doing teaching and learning, right? And it's actually changing the way that we are doing this gaming entertainment, right? And to some extent, it's going to change the way that we perceive the world as well. Right? If you look at the VR and AR technology. Anything else? There are actually many more. Anything else that come to your mind? Anyone want to chime in again? What else? How about this one? Anyone recognize this one? This is the so-called Bitcoin, right? This one becomes, right, sort of a huge buzz, right? So recently, but this Bitcoin is not just about digitizing the payment system, right? It's actually more than that. It's actually digitizing the entire currency system. That's why this thing becomes, so interesting, right? And there's so much hype, right, beating around this thing. Right? Of course, we also hope to rely on more of these digital systems, right? So in this special time, right, I'm pretty sure the digital system is already, changing the healthcare system as well, right? Like I mentioned, there are many more, right? If you have anything on your mind, let me know, right? Again, you guys are probably too young to know this movie, right? There's this famous sci-fi movie called Inception, right? Okay, it's really about digital dreaming, right? So that movie is kind of forward-looking still, okay? It's really about hacking into other people's dream, right? But believe it or not, right, actually many researchers, also companies that are indeed trying to build this sort of machine, right, brain-machine interface. So I'm pretty sure in the future, if not in the near future, right, so this digital dreaming may become a reality, right? So that's where maybe you will be given this option, whether you like it or not, right? You may choose to take 2300 in your sleep time. Okay, so this may actually solve a lot of issues with this remote learning, right? It's the time difference issue. All right, so again, there are just many more. But actually want to bring up one more buzzword. We just talk about digital, right? We talk about autonomous, we talk about smart, right? So there's another buzzword called deep. Okay? I don't know how many of you have heard about this concept called deep learning or deep neural nets, right? So this is actually the technology that sort of empowered the new resurgence of AI, right? So one of the remarkable developments is this Google AlphaGo, right? Hopefully you guys have seen the news, right? It's about 4 years ago, right? March 2016, right? This is actually the first version of AlphaGo actually won the match, right? Again, it's a very top Go player, right? ECE2300. This is a big thing, right? If you happen to know the rules of this game, right, this Go, happen to have played this game before, you'll probably know how hard this game really is for human. Okay, so this is truly remarkable. And also, I really like this picture, right, painted by economists, right? You can see this is sort of a gloomy picture, right? From this picture, you can almost sort of smell the frustration and fear, right, from the human player. Okay. Now, of course, this is not really a fair comparison, right? It's not really apples to apples, right? So competition in the sense that there's a human player, and if you look at this picture, there's another reason I really like this picture, right? So this whole thing, right, it's really powered by thousands of machines, right? Thousands of digital computers. Actually, they're using more than close to 2,000 CPUs and GPUs, right? To really do the compute, right? To do the calculation, to do the number crunching. Okay, so that's where, but still, so this is a truly impressive in development. There's the old saying, right? If you cannot beat your enemy, you join them, right? This course is actually a good start, hopefully for many of you. So we want to understand what exactly is going on, right, in this digital computer. How come they're now so powerful? Okay, so that's actually 4 years ago, right? This is a more recent deep learning model. It's called GPT-3. So this is developed by OpenAI. This is a Silicon Valley-based lab. It's actually so the AlphaGo is more about game playing, right? So this one's more about natural language processing. This one is actually surprisingly good in terms of generating this human readable text. Right? Hopefully the font on your screen is big enough, okay, for you guys to read some of this automatic generated text. This is actually an email generated by GPT-3. Okay. If you're a fan of Big Bang Theory, right, you may find this email sort of amusing. Okay. And now I'll give you guys some time to read this. Right? And there's another tweet, right? This guy actually ran the GPT-3 model and then use it to generate this a more serious article. Okay, so actually this guy just entered some keywords like unsolicited advice, like over here. I don't know whether you can. Okay, like over here. Okay, and that's it. And just enter the author name. If you actually read this, just read the first paragraph. I hope you'll be as surprised as I was. Right? This is actually pretty real, right? This does not look like something written by a machine. Okay. Right, and also I really like the term that this guy's using, right? This tweet, right? Artificial thought, often artificial fellow. Okay, and looks like pretty soon, indeed, we'll be able to buy books, right, written by these machines. Again, one thing I want to quickly point out is, right, so if you look at the thing that I'm underlining here on the left, right? So this is what the title of the article is, right? So I really like, right, the word they're using, right? Although this machine learning model, deep learning model seems really powerful, they're actually not that intelligent, at least not in the traditional conventional sense. So to this author, they're actually completely mindless. So this model are just trained on massive amount of data, and they're actually running on massive amount of CPUs and GPUs. Right? To give you more data, so actually just to train a model like this, the cost is estimated to be close to $5 million. Okay, this is sort of also mind blowing, right? But again, this really means that this whole thing is really empowered by this huge amount of compute power, right? So by the digital computers, right? Actually, this is also something, how to reduce this cost, right? How to make these machines, how to make these AI models, right, a lot more efficient is also a very active research area, something that even my research group is looking at. Okay, so hopefully, you're now sort of interested enough, right, to learn more about this digital computers, right? So let's just start with actually a simpler one. Okay, let's start with something that's embedded in your iPad, right? This is actually the first version of iPad, right? This is actually a 10-year-old computer. Okay, but even for this one, it's fairly complex, right? So if you actually look at what's going on under the hood, right? So usually you'll find so-called PCB, printed circuit board, right? And on this PCB, there are many subsystems. So we call the subsystem as chips, right? So these are the chips. Okay. We usually call them as IC or integrated circuit. Okay. And these ICs, they are also very complex. They're composed of many, many modules, right? And if you further decompose these modules, so we can find the so-called standard cells or cells. Okay. And we can further decompose them into something called gates. Right? So these are actually the physical layouts here. So this is not something that we need to worry too much about, right, in this course, right? But I just want to show you that these are actually non-trivial, right? So they're actually non-trivial amount of engineering going on. And we can further decompose it, right? So that's where you guys probably can see that it's a familiar term, right? So you're seeing this so-called transistor, right? It's underneath, right? In the end, we have transistors, right? So which are the fundamental building block. And of course, we also need to make sure that this transistor indeed perform in the right way, right? So that's where we need to design the right scheme, right, to represent how we process, also how we, encode the information. So this is where we are going to talk about the digital information or digital abstraction. Okay, so one thing I want to quickly point out that, even for a simple system, this is actually a relatively simple computer now. Okay, again, 10-year-old, right? This is for embedded, right? So this is a portable device, iPad. So even for a simple system like this, right? We have actually between 1 to 2 billion of transistors. Okay, we actually have a lot of transistors. So then you may ask, right? Given the complexity of such system, right? How do we actually try to understand them? How do we actually try to attempt to build them? Okay. So here's our approach. Instead of trying to build the whole thing from in one shot, okay, so that's not a good idea, right? So we'll try to understand things bottom up, right? So by bottom up, let me go back to the previous slide, right? So we'll try to understand these fundamental building blocks first, right? There's some smaller things first. And then we try to layer the so-called abstractions, and we will try to build slightly more complex things, right? So one step at a time. So that's what I mean by bottom up. Okay. And also one important thing is this term is going to come up very often, right, in this course and also in this lecture. Okay, we're going to build up these sort of abstractions. Okay, so that's where we can sort of hide or abstract away some of the important, but some of the low level. Okay, so important for the lower level, but less important for the higher level. Okay, we want to hide away some of the lower level details so that we can use these building blocks to build something even bigger, right, even more complex. So we can form even more complex building blocks. That's how we do it. Okay, that's actually sort of shown right in the previous slide. Okay, we basically build these systems bottom up. Right, so that's how we do it. And also this is also the flow of our entire course. And the other thing is, we really want to make sure that you guys develop this hands-on experience. Okay, so we will need to make sure that you guys actually build something for real. Right, so this is where I think I already sent out this note, right? I posted this note on Piazza and also sent an email. Hopefully, most of you have received an email. I know some of you joined the course a bit late, right? In case you haven't seen the announcement yet, right? So make sure you submit this board request, okay, to the ECE department. Okay. There's a Google form. I just created a shorthand, right? TinyCC, right? ECE2300 FPGA. You can just use the link to submit a request. Right? This is extremely important. Okay. We're going to start the lab, the FPGA lab, in about maybe 3 weeks, right? So I want to make sure that all of you get the board, okay, before we start the lab. All right. So these are, the main approaches. Okay. And about the textbook, right? Hopefully, most of you already have a copy of this book, right? This is the book written by David Money Harris and Sarah Harris. We usually call it the Harris book, or HH, okay, for short. Please get the second edition. Okay. And there's also this ebook available online. Right? The link is on the course website. Right. So make sure you get the MIPS version, not the version. And like I just mentioned, right, there's actually a course website. Okay, so this is also the link is also included in my previous announcement. We are not going to be using Canvas, right, in this course. So most of the information will be either on the course website. So this is actually a public website. So that's where you get to see the lecture slides, right, syllabus, and some other handouts. And also a lot of things will be posted on Piazza. Right. Actually, one of our TA just asked, right, I just clarified. Most likely, we are actually recording the lecture, right? And we plan to most likely post the recorded lectures as the links on Piazza. All right. And for assignment and grading, so we are going to be using CMS. Hopefully, many of you have used CMS before. Okay, so this is where you need to, of course, we are doing remote learning, right? You guys need to submit everything in the electrical form. Right? You need to submit a PDF, and in some cases, zip file. Okay, any questions so far? Okay, now let me quickly introduce our TA team. Right, we actually have a group of very strong, very capable TAs. We have 2 PhD TAs, Nikita and Lisa. Okay, we also have a group of very bright undergrad TA, Peter, Raleigh, Franny, Alex, Elga, Arun, Danny, Emmy, and Xiangyi. So most likely you guys will get to know them pretty quickly, right, during the office hour, also during the lab sections. You can also reach us. So you can reach me and the TA, so all the TAs using this email alias. Okay, right, again, this is going to be, I'm going to release the lecture slide, right? So also this is, I think this link, this email address is also posted on the course website. So one thing I want to quickly mention is actually most of the TAs are just doing this for service, right? Really out of their passion. So they're really passionate about this course, right? They really want to help out, right? But you guys have to understand, these guys, they also have their own coursework, right? They have their own research. In many cases, they're also busy, right? So try to be patient with them, right? Try to be nice with them. Okay. So again, these a group of very strong and very capable TAs. Okay, and in case you need help, again, you can go through the Piazza forum, right? Ask questions there. Okay, I'll try to answer some of those questions, and also TAs will be there. And I just mentioned this email alias, right? ECE2300 stuff. If you have some private matters, right? For example, if you have missed classes, right? If you have a schedule conflict with certain classes or exam, send me an email. Okay, feel free to directly email me. My email address is also on the course website. You can also come to my, of course, right? This is gonna be virtual, right? Office hour. So this is gonna be on Thursday. So my office hour, also all the TA office hours will start next week. Okay, so we'll post the sort of first lab, and also we'll also post the first assignment homework soon. And we will not have any TA or instruction office hour this week. Okay. All right. Okay, so let me introduce myself a little bit, right? And my name is Jiru Zhang. Okay, so that's how you can pronounce my name. Okay? You can also just call me Ziru. Either Ziru or Jiru is fine. You can also just call me Dr. Zhang or Professor Zhang. Actually, the pronunciation for my first name is not exactly the correct one, okay, but it's actually the closest one. So I have already made my peace with it. Okay, so this is good enough. And I'm currently an associate professor of ECE. I'm also a faculty member of CSL. I can actually tell you a little bit more about myself, but this is where actually I want to interact with the class a bit. So using this website, it's called itempool.com and ECE2300 Live. Okay, if someone can help me put it on the chat window. I need to switch my screen. Again, make sure you guys go there. Okay, and there might be a prompt for your name. Just enter a net ID. Okay, so this is actually important. This is going to be an important exercise because we're going to be using this website to do some of the in-class exercises and also quizzes. Okay, this is not a quiz. Okay, so this one is just for fun, right? Just want to make sure that you guys are familiar with the system. All right, let me change my screen. Give me a sec. Okay, I need to switch to a different screen. All right, so hopefully most of you are there. Okay, again, go to this website, right? This is the cool. Okay, the answers are already rolling in. Okay. It looks like there are two major opinions, pretty much evenly distributed. Nice. Okay, all right. So there's a third opinion. We're not going to review the answer right away. Okay. But you guys can see that actually some people are changing their mind. You can see this live. Cool. All right. I think most of you have already entered your opinion, right? Okay, so let me just read this, right? So these are some of this is actually one of the icebreakers that I did in the previous classes, right? Of course, it's not that easy to do it, right? Online, but this is my sort of best attempt. Okay, this is sort of a two truths, one lie, right? Sort of thing. Okay, although indeed there's a fourth option. Okay, let's see. All right, indeed they are changing their mind. Let's see. Okay. Right, so two of you, okay, believe that I do not like student in my office hour. Okay, all right. And most of you are saying that I don't really have a very good memory. Okay, I cannot easily spot who are absent from class, right? And also I am really glad to see that as in the majority of cases, you guys really have strong faith in my memory, right? Okay. And the answer, right? Of course, this is all of these statements are very subjective, right? So at least to me, the correct answer is none of the above. Okay, right. Cool. Right. Thanks for participating. Okay. Hopefully, again, make sure that you guys enter your net ID right later on. Okay. I think there's also a place where you can check what's the current name that you enter. So later on, like I mentioned, we're going to be using this to do some live challenges, in-class exercises, including quizzes. Okay. Of course, this one is not going to be graded, but some of them will be graded, and I'm going to give you a heads up. All right. So let me go back to my. Okay, let me go back to my lecture screen. Okay, right. So it's great that this move works pretty smoothly. Okay, this is probably one of the more important slides. Okay, for you guys, this is the how we break down the grading, right? Some of the points. Okay, we have many categories, right? I do hope that you guys will participate in the class. I'm going to mention this, right? There'll be 3 prelims, actually 2 prelims, 1 exam, 3 exams. And the quizzes, right? Like I mentioned, homework and labs, right? So the way this distribution is designed is, we want to make sure that there are actually many ways for you guys to succeed in the class. Okay, let's just look at some of this, right? There's actually 3 points, right? Allocated for in-class participation and also offline participation. Okay. So later on, actually, we already did some of this, right? So some of you have already participated, which is great. So I'm going to be asking questions, right? I'll ask, students to chime in, right? So I'll also pause, right, from time to time to see whether there's any questions on the chat window or not. Okay. And when you guys actually ask a question, it would be really great if you can just unmute and toggle, right? Turn on your video. Okay. Of course, you want to mute afterwards, right? And we just did some live challenges, right? That's actually based on the item pool. We're also doing some polls, and later on we may also, most likely in the second half of the course, we may also do some bonus questions. I still need to figure out what exactly is the bonus. Okay, we'll see. And also you can directly contribute to the class through Piazza as well, right? You can ask questions and help other students. Right? So here's a very rough rubric. If again, if you trust me, right, you trust my memory, I tend to be able to remember names, right, if they're actually very active. So you're going to get 3 points, right, 2 points. And if you're someone engaged, right, so 1 to 2 points. If you happen not being able to contribute to this in-class discussion, also Piazza, then unfortunately, right, so that's going to be a no impression 0 point. Okay. And more about the labs. There's a question, I think. See in a sec. Okay. Does engagement in the chat count? Yes. Right. Right. Again, like I mentioned, right. So I'm gonna hopefully be able to pause, right, from time to time and look at the question in the chat window. But in case I forget, feel free to remind me. Okay. Right. So we have 4 labs. Okay. Labs is actually one of the major components. We have 4 labs in total. Okay. And per lab, usually we have 3 components. Okay. So one is pre-lab. Okay. So that's something that you have to complete before the actual lab section. And then there's this actual lab sections, right? All of you are assigned to one of the lab sections. So again, this is going to be your virtual. In the lab sections, this is where you implement, test or debug your design on the FPGA. And this is also where you can, interact with the TAs, right? So, extensively, and also this is where you check off your design. All the due dates are going to be posted, right? I think many of those are already posted on the course website, right? We also send out the due dates when we release the lab handouts. For some of the labs, actually for the first lab, the pre-lab and actual lab is the same thing. So there's no actual lab. Right? We'll just ask you to submit one pre-lab just to get you warmed up. And for some of the labs, so we also ask you to turn in a lab report, okay, after you're done with everything. Okay. So again, 4 labs. Right? So this accounts for about 28% of the points. And also we have about 8 in total problem sets. We'll be releasing one soon, most likely next week. The whole thing accounts for 14% of the points. Okay, and we will have 2 prelims, right? So both of them will be in class. The reason that we're doing it in class is just way easier for me to schedule things, okay, to avoid some of the schedule conflicts. The first one is going to happen in a month or so, on March 16. Second one in another month, right, April 20th. Okay, again, both of them will be in class, and we'll figure out the format soon. There's no date yet on the final exam, but final will account for about 22% of the point. Okay, and also I want to make sure that you guys know this, right? So there will be in-class quizzes, okay, in most lectures. So that's where you guys really need to pay attention. Okay, we are going to be using item pool. Okay, again, so I'm going to give you a heads up, right? At least 1 or 2 slides earlier, prior to the quiz, I'm going to let you know. So a quiz will start soon, okay, so that you guys are prepared and you guys start really paying attention. And we'll be dropping 4 lowest scores. Okay, so again, there'll be many quizzes, but we'll drop the scores for some of them. Okay, right. So let's see. Alma, just another question on this chat window. So do we still need to go to the lab section weekly, or we'll only attend it 4 times? Okay, very good question, Alma. Right, so we are going to be announcing some of the labs very soon, so we'll let you know the actual logistics. The thing is, actually, for many labs, so for example, starting from the second lab, including second lab, third lab, fourth lab, they'll be further broken down into multiple sub labs. Okay, so that means you guys do need to go to lab session more than 4 times. Okay, most likely, again, check out the course schedule. I have already posted everything. And the first virtual lab section will not start, at least not in the first 2 weeks. Okay, I did mention that in one of my announcements. We will let you know. Okay, then is the first lab section. Everything is based on Zoom. Okay. Any other questions about exams and quizzes? Okay. If not, should I mention a few other important policies? Okay, so one thing is I do need you guys to submit everything on time. Okay, if you're late, then you get 0 points. Okay, unfortunately, so this applies to everything. Okay, usually the due time will be 11:59 p.m. basically midnight. Okay, end of the day basically. Again, this applies to everything: homework, pre-lab, lab reports, right? But there's some exception, right? We usually allow you to submit up to 2 assignments. Right? So one more time. So this assignment includes homework, pre-lab, and lab report. Okay, not just homework. So you can submit up to 2 of them late. Okay. And you also get allocate something called slip days. You get 7 slip days in total. You can allocate them however you want. Right? For example, you can allocate 1 slip day for the first late assignment, and then you use up 6 slip days for the other late assignment. Or you can do 2 + 5 or 3 + 4. Okay, right. But for pre-labs, you are only allowed to submit this thing late by at most 2 days, up to 2 days. Okay, because we do need the TAs. We do want the TAs to grade your pre-lab before the actual virtual lab session. All right. Okay. Right. So yeah, one more time. We will not have any virtual labs, right? So in the first 2 weeks, we will make an announcement when it actually starts. Okay. And also, you guys may, in some cases, you may want to submit a regrade, right? So a regrade request. So that's where I'm going to post a regrade form on the course website. So just make sure that it's submitted 1 week after the grading is done, right? Within 1 week. So there are actually, like I mentioned, many ways, right, to do well in this class, right? You can participate, right? You can make sure that you attend most of the lectures, right, and complete the quizzes. And it'd be really useful if you can read the book sections before the class. I'm gonna post the chapters, right? So which chapters are gonna be useful, relevant to a specific lecture. I'm gonna post that right before the class. And also you can find all this information on the course website. And also make sure that you do not submit assignment late or too many of them late. And just ask for help, right? If you need any. Okay, so there are many ways to ask for help. So I just want to quickly mention that this course is actually, not supposed to be too hard, okay, for most of you. Okay, based on my experience, this course does not really cover, any of the rocket science. So you'll soon find out that it's really more about understanding the intuition. It's really about intuition, right? Developing intuition behind certain new concepts, right? And also understanding some of the trade-offs involved. So, this is where that I'll try really hard, right? In many cases to give you analogies, right? So to try all sorts of things, right? Exercises, right? So to give you guys the opportunity to develop this kind of intuition, right? But, in case that you find certain things are not that intuitive to you, right? Just ask me, right? Ask the TA. Again, you can ask questions, right? During lectures, or ask questions in my office hours or TA office hours. Okay. All right. Okay, and this is something that's pretty obvious, right? I'm not gonna read it, right? So I know that all of you guys are familiar with this, right? Just want to make sure that this came across, right? So there are actually certain course websites, actually not commercial website, where you can buy or sell course materials, right? I think there's a website called Course Hero or something, right? Don't do that. Okay, you guys are smart enough not to do that. There's a very fine line between course hero and course zero, right? The moment you do that, people will find out. Okay. All right. Any questions? Any more questions? Let me quickly check the chat window. Okay. Right. So maybe let's take a break soon. But before that, I have mentioned this course website many times, right? Hopefully you have already checked it out. This is where we have the complete course schedule mapped out. But this is a tentative one, so I still may need to change, right, and adjust in some cases. But you can quickly find out, right, when are things due, right, and what are the chapters to read, right, before each lecture and such. Okay, and just go there. And the important thing is make sure that you guys read the syllabus. Okay, I've already covered most of the important things about the syllabus, but make sure that you guys actually read it. Okay, so there are some certain details that you may want to, right, so understand and also remember. Okay. Right, so if there are no more questions, maybe you can take a 3-minute break. Okay. I'm gonna talk more about this digital logic and some of the more technical content. Right, so I'll come back in a few minutes.